Uh, Today we'll see how to solve the kth largest element in an array. So here we are given an array without sorting and we want to find the kth largest element. If k is 1, means we need to find the last element in the ascending sorted array. Got it? If it's 2, we want to find the element which is second from last in the ascending sorted array. But we have to do it without sorting the entire array. So let's see how we can do it. Here I have taken an array and these are its indices. It's a sorted array. We'll use it to get better understanding. We won't use it directly to get the value. So we want to find the second largest element. So what would be the index of the second largest element in the sorted array? Index of the first largest element will be the last index and index of the second largest element will be the one before that. So we want to find the element at index 10 in ascending sorted array. So how do we do that? So the approach I've used was similar to quicksort. I've chosen a pivot instance. So from this array, from main array, choose a random index. Let's say I've chosen 5 and the value at that index is 3. So now I divide this array in 2 parts. Low value and high value. All the elements less than 3 will be here. All the elements greater than or equal to 3 will be in high value. So let's go from the start. 9, it's greater than 3. So it will be in high value. 2, it's less than 3. Similarly, 1, 6, it's greater than 3. 7, it's greater than 3. 3 is equals to 3. 4 and 1 is less than 3. 3 is equals to 3. 2 is less than 3. 8 is greater than 3. And 1. Okay. So these are the elements. Now, indexes of these elements are 0, 1, 2, 3, 4. And indexes of these elements are 7. Okay. So we can observe a property here. All the elements between index 0 to 4, what are the elements? 2, 1, 1, 2, 1. So 2, 1, 1 and 2, 1 will be between 0 to 4, index 0 to 4, even in the sorted array. So index 0 to 4 instance from here till here. If you see in the sorted array, the elements are 1 and 2. Even here the elements are 1 and 2. We split the array in such a way that the relative positions between these indices will change, but these will not go out of these indices. So 2 will always be in between 0 to 4. Okay. So from this we can infer that the element at index 10 will not be here. It will definitely be here. So what we do is we again recursively do the same approach. Okay. This is the array we got now. Okay. Its base index is 5. So choose a random index. Okay. Let's say it's the index is 6 and the value is also 6. So again I split it. All the elements less than 6 will be here. All the elements greater than 6 will be here. Okay. So let's start. Again 9 is greater. 6 is equals to 6. 7. 3 is less. 4 is less as well. 3. 8 is greater. So now these indices are 5, 6, 7, 8, 9, 10 and 11. So we know that the element at index 10 will definitely be in this. Okay. To narrow it down again, we can do the same recursive procedure. Or when the number of elements are less than m, some certain value, you can choose m. Okay. We can directly sort it because here we have 4 elements. So if we sort it, the time complexity will be less than uh, doing recursion and finding it. So if I sort it, the values will be 6, 7, 8, 9. Their indexes will be. So we know the element at index 10 is 8 and we return 8. Okay, we could have done this recursively, but that takes more time. So if there are very few elements, what we can do, we can directly sort them and find the value. So now let's see the code. So we are given an array and base index just to keep track, and what is the index that we want to find. So if the elements are less than 1000, I'm directly sorting it and finding the index. Okay, if not, I choose a random value and just calling it as mid value, but it's random, and all the elements less than mid value will be sent into low, all the elements greater than or equal to mid will be sent into high, and if the index we want to find is greater than the indexes in low value, what we do is we go towards high value. If not, we recursively solve the low value. Okay, that's